Hello, my name is Sinkala, aka Professor Ras. Let's try to explore in chemistry 110. Please don't forget to subscribe, share, comment, and also like for encouragement, and also for further information if there is anything to add. Okay, so I won't take that much. I just want to take this video in 5 minutes, of which this is the first topic that we are going to take in Chemistry 110. And in this case, we are talking about the naming of simple compound, and also the naming of simple, that is the naming of compound. Now, in this case, the naming of compound is being classified into two. There is what we call binary compound and also tertiary compound. Now, in this case, I'll just try to explain briefly binary and compound, and go back to binary. Then tertiary, ternary compound we'll discuss later. Now, in this case, binary compound, they are ionic compound, or they undergo electrovalent kind of bond. So now, in this case, the binary compound only consists, those are some of the characteristics. In this case, if the question might come, or let me say, if you want to differentiate or distinguish between binary and ternary, binary compound, they consist only two elements, or they are diatomic. They consist of diatomic element, which means they consist only two elements, and their element you can only find. Also, these are popular elements that you can also find on the periodic table. And some of the examples of binary compound, for instance, group 1 element react with group 2, let me say, bond with group 7, group 1, group 7, bond with group 7, of which they form binary compound. Group 2 bond with group 2 bond with group 6, forming binary compound, because it only consists of two elements, and also it undergoes electrovalent bond. So that is binary compound. Group 3 element bond with group 5 elements. That in this case also forming what? Binary compound. Now in this case, what about ternary compound? Ternary compound is compound which consists 3 and above, let me say 2 and above compound, and in this case sometimes they call them to say this polyatomic element. And on the other hand, this mostly consists of D block metals or heavy block metals, or let me say transitional metals react with any other compound or any other elements, and in this case they're forming ternary compound. So they consist 2 and above compounds. So now let's go back to binary compound. Binary compound, like what I've said, binary compound, they consist of 2 and above compound. And in this case, this 2 and above compound, they consist of 2 compound only, which is the atomic compound. Now, there are some of the rules that attach to name binary compound. Now, like what I said, I'll start with binary compound. I'll start with binary compound. So I'll start with binary compound. So in this case, these are binary compound. Now, what some of the rules that attach to it are is, the first name has to come from the cation. When I say cation, it is the charged, it is element with a positive ion, which is charged with a positive ion. In this case, for instance, I gave an example of group 1 element that being charged with the positive, positive ion with a, or positive 1 ion, or positive 1 charge. Now, in this case, the first name has to come from the metal, or the first name has to come from where? From a cation. Secondary, or the secondary is this, the second name has to come from where? Anion. When I say anion, I'm talking about non-metals. Or when I say anion, I'm talking about the negative charge element. Now, or metal, or I mean non-metal. Now, what's going to happen here is this. If the first name has come from a non-metal, I mean a metal, which is a cation, second name coming from a non-metal, which is anion. Now, the third rule is this. The name of the cation or the name of a metal has to come from a monoatomic element, which means the element itself. Nothing has to change to that. Then the fourth rule is this. The name of the anion has to come from the root code IgE. So from the root code IgE, that's why, for instance, you may find to say there is sodium chloride. Chloride from chlorine. Chlorine is a non-metal, right? Having a negative charge is an anion. So in this case, that's why I may find to say, if it is sodium, for instance, this is a symbol for sodium chloride, right? This is a symbol for sodium chloride. So I'm going to say, sodium as a metal, right? Sodium as a metal, and also sodium as a cation, a first name, following the rules, right? Yeah. So in this case, let me try to write some rules here to avoid those kind of issues. So first name, coming from where? Metal, which is a cation. Second, or name of non-metal, or second name has to come or come from anion, which is a what? A non-metal. Then, the name of the metal has to come from or should come from monoatomic element. If it is sodium, it is sodium. Then, name of the non-metal has to come from root code IgE. So whenever we are naming a binary compound, the last name has to end, for instance, and there has to be indication of, or let me say, there has to be appearance of IgE. For instance, I've got sodium chloride. Like what I was saying, yes, I've got sodium chloride. Like what I was saying, I've got this is a symbol for a chemical formula for sodium chloride. In this case, this sodium chloride, the name is this. Sodium chloride, right? And if you see very much properly, this is a chemical formula, right? So in this case, this is the name of itself. Inward. So what's going to happen, this is sodium chloride. This is chloro from chlorine, right? This is a symbol for chlorine. And chlorine being in group 7, it contains a negative charge, right? And it acts as an anion, which is a non-metal. Now in this case, A non-metal or anion, the ending or the root has to be, has to have what? IDE, right? Now in this case, if you see very much people have got sodium chloride, IDE. That symbolizes to say, wherever you are naming any binary compound who have such kind of what? Such kind of ending. Now in this case, we'll take some of the examples in this case to go ahead with this kind of understanding. For instance, if we pick group 1 element and group 7 element, and what's up come in your mind is this group 1 element, these are metals. Group 7 element, these are what? Are non-metals, right? And if you pick group 1 element, for instance, I pick sodium. This is a periodic table, right? I pick sodium. Sodium is in group 1. This is sodium. So, sodium is in group 1. So, for instance, I pick sodium, right? And for sodium to be in group 1, which means it is being charged with positive, it's being charged positive with positive 1. You know, to say metal, always the charge has to be positive. Non-metal, the charge has to be negative. Which means if it is negative, which means it is receiving the electrons, or it is gaining the electrons. If it is positive, as in metal, which means they are doing what? They're sharing electrons. Or, they are giving out electrons. So if I get sodium in group 1, and I also get, I get fluorine. Fluorine is in group 7. So with the chemical symbol of F, which is fluorine, right? So now watch out what's going to happen here. I do this. I say, this is sodium. Sodium is in group 7. Fluorine is in group 7. Then sodium is in group 1. Right? So for sodium being group 1, and honor to say, group 1 those are F metals, right? The metals. So what's going to happen is this. They contains a positive charge, which is positive 1. Right? Also fluorine. Then in group 7. Now in this case, we cannot put a 7 as a variance, no. First of all, doing with variances here. Right? So what's going to happen for us to determine the variance of fluorine? What we're going to do is we say 8, which is the maximum number of electrons in outer shell, minus 7. The same group, and they're having what? 1. So the variance of fluorine is 1. Right? So the variance of fluorine, we put what? 1 here. Right? So here are going to be exchange of what? Valences. So the valence of sodium is 1. The fluorine is 1. And on the other hand, the charge for sodium it is positive 1. The charge for fluorine is negative 1 because it's a non-metal. Because you know to say, starting from group 5, 6, 7, up to 7 there. Those are what? Are non-metals, right? Now, see what's going to happen. I put sodium here. I put fluoride here. Right? The same thing. Then they're going to do what? To share or to exchange their valences. This one comes here. This one comes here. And so we're forming what? Something like this. Right? Sodium, which is Na and F1. And I can like this, right? I know to say 1 is invisible. Right? And this person also will say a person is 1. Let me say one person is 1 person. Let me say I cannot write sodium 1 or fluorine 1. No. I have to write sodium. So I know to say sodium, which is Na, it's 1 itself. Fluorine, it's fluorine itself. Right? So if I say sodium 1, I'm repeating it. I'm repeating myself. So what's going to happen here, I say, or our chemical formula here going to be sodium fluoride. Right? Now, in terms of naming, this is our chemical formula. Now, what about the name? Here's the name. the name has to come from, the name of metal has to come from monatomic element, which is no any change, it is element itself. So sodium, right? Fluoride. From fluorine, right? IDE. The name of non-metal, which is anion, has to come from where? From the root code what? IDE. Right? So for instance, again, I get group, another example. I get group, so for instance, group 2. I'm not saying in group 2 there is magnesium. I get magnesium, which is Mg, right? And also I go in group 6, right? Because I know to say the sharing in or the giving out of electrons, it has to be the gaining of electrons. It has to be equal to the gaining of electrons. So magnesium must react with, since it is in group 2, has reacted with those elements that are in group what? 6. Because those elements that are in group 6, they'll be receiving 2 electrons for it to be stable, or for them to achieve acted role. Right? So what's going to happen is this. In group 6, this is group 8, this is group 7, this is group 6. We've got oxygen. For instance, let me get oxygen, which is O. Right? So here we go. Here we go. We want to say magnesium is in group 2. So for magnesium to be in group 2, what will be the valence of magnesium? The valence of magnesium will be what? 2. What will be the charge of magnesium? The charge of magnesium will be what? Positive 2. Since it is a metal, it is a cation. What about oxygen? The oxygen, the charge will be what? What a bit? We want to say any compound to achieve an acted role. Or let me say any compound in our outermost shell, for it to be stable, to achieve acted role, has to be having, let me say, that element should have what? 8 electrons. So for instance, I get 8 here, right? And in this case, we want to say oxygen. The proton number for oxygen is 8, right? So what's going to happen here is this. If I'm to write, let me say, electron configuration, the one that we are using in grade 12, right? We want to say the first shell should have 2 electrons. Then the second shell, of which if you subtract 8 minus 2, we should have what? We're having 6. So let me say the outermost shell for oxygen contains 6, right? And the outermost shell, which means it's not stable, mostly should have 8 electrons for it to be stable, which means there's remaining with 2 electrons for it to be stable, right? So 2 electrons that are needed here. So these 2 electrons, if I have to subtract with these, the number of electrons are supposed to be 8 in outermost shell. Will remain with the same. Let me say, if I have to subtract this 6 with the same number of electrons that are supposed to be in outermost shell, will remain with what? These 2. So of which that symbolizes to say the valence for oxygen, it is what? It is 2. Right? In this case, to find the valences of each and every element in our periodic table, just subtract with, let me say, especially the non-metal, only the non-metal or anion, subtract with 8. Then the metal just get, if it is in group 1, get the same group number. If it is in group 2, get the same group number. Now, what else is going to happen? So of which the charge will be negative. Since it is an anion, right? It will be negative 2. So now, what will happen is this. You go ahead. I say, I drop magnesium here and also oxygen, right? Of which they're going to exchange their valences, right? These 2 comes here. These 2 comes here. So I'm going to have magnesium 2 here and oxygen 2 here. Right? And if I'm trying to reduce it, I can write like this, right? Of which 2 into 2, 2, 2, 2, gone. So I'm going to remain with what? Magnesium oxide. So this is the formula for what? Magnesium oxide. It is a binary what? Binary compound. So thank you. You can get more and more examples. You can follow more and more examples just to open up your mind. You can try groups 3, reactive group 5, or group 1, group 1 and group 7, get another element there, or group 1 and group 6. You can try to get all those kind of examples. Thank you very much. Don't forget to subscribe, to like, share, and also comment.